Hi guys, where we left off I'd tested two of the input port bits, fire and power LED, and I was waiting for a floppy disk drive to test the rest of the port bits properly. But is that all we could really do? When I said I'd discarded these PCB terminal strips, I hadn't really discarded them, they were just kind of discarded from the project and waiting for reuse for something else. The something else is an output port test jig that I'm going to connect to the floppy drive port to test the output bits with LEDs. This will make it easy to visually check the status of the port bits. This is the way the LED test jig will be displayed to you, the viewer. BFD100 is the location that the device is providing an output port for, and that's the location we'll write to with some Amiga software. The motor signal on the floppy port is a bit of a hack job, and I can only guess it's done to accommodate floppy drives, and we don't have direct access to that signal. The output bits for Select 2 and Select 3 exist on the board, but I haven't wired them to the floppy port because I don't plan on using them. I've written a small program in WinUAE using a DICE compiler. Every second it alternates the value that it writes to BFD100 between FF and 00 hex, so that's all bits set and all bits clear. Of the 8 bits on the port, I have proper access right at the moment to 5 of them. 2 of them simply aren't displayed and 1 of them is synthesized by the circuit. I've left the actual load times here from the CD. I won't have to boot from CD when I have a working floppy interface. But anyway, this is done for authenticity. I'm going to be destroying some of the test jigs for this test after the test is done. Okay, and there's 5 of the output bits flashing. The motor LED is working because it changes state at reset and power up time, but it's not controlled by the program. But I'm not worried about that for now. I've got a slightly different version of the program. This one rotates a set bit in a buffer and keeps writing that buffer to the output port. When the fire button is pressed is when it does the rotation, but the output port is constantly updated. The CD32 infrared remote receiver for CD32 is an entirely different project on my channel, but when you see the CD32 remote, pressing fire is the same as pressing fire on the CD32 gamepad or a joystick. I didn't handle the fire button very well. Whenever it's held down, the bits are rotated very fast, and sometimes it can land on one of the bits that aren't displayed, which is 3 possible bits. But it does rotate through all the bits and work as expected, so I'm happy for now. Maybe I'll make a jig of switches and test the inputs as well. It's not really out of boredom I'm doing this, it's impatience for the floppy drive to get here. One of these LEDs is hard connected to power, and the other is the Amiga power LED, which is software controlled, and when I press reset it'll flash briefly. One of the chips has arrived, the LS541. I'm going to use all original components when I do the original PCB version. It doesn't really help with the cost for the availability in Australia, but it'll be neat. That's all for now, catch us next time.